Hey guys, 2-3 direct variation. You also have a second video in Schoology. There's a link. It's short, it's 2 minutes. This might be something that you're more interested in watching. Direct variation is something that's very easy, but it's also something very confusing for some students. So therefore, I'm going to also put the additional textbook examples up uh, so that you have that. It's better to have more than enough than not enough, in my opinion. All right, what we're looking at today is writing and interpreting direct variation equations. Okay, example one. Before we get started with this example, a direct variation is any linear function defined by the form, or defined by the equation of the form y equals kx. There is no constant being added to or subtracted from, meaning that your y-intercept is always, always, always going to be 0. So it's always going through the origin on a coordinate grid. Okay, the constant of variation is the k. It's the coefficient of the x in this particular example, and you can find that quite easily. If they give you y equals kx, they give you the y and the x, you plug that in and you solve for k. K is equal to y divided by x. Okay, so that is your constant of variation. All right. So for each function, determine whether y varies directly with x. If so, find the constant of variation and write the equation. Okay, so going back up here real quick, it says the constant of variation is equal to y divided by x. Okay, so you're going to do k equals y divided by x. So this is the y, this is the x. So you've got 3 over negative 1. You have negative 6 over 2. And you have 15 over 5. Well, this simplifies to negative 3. This simplifies to negative 3. This simplifies to 3. In order for this to have the same constant of variation, they would all have to be the same value. These are both negatives, and this one's a positive. So this one is not a direct variation. Your y does not vary directly with your x. Okay, looking at part B, we have 14 over 7. We have 18 over 9. And we have negative 8 over negative 4. So this gives us 2, this gives us 2, and this gives us 2. Those are all the same, so your constant of variation is 2. And find the constant of variation, k is 2, and then write the equation. We know it's y equals kx, so then it's just y equals 2x. Very, very simple. Don't overthink it. Don't overwork it. Okay? All right, so now let's go ahead and take a look at example 2. We've got identifying direct variation from an equation. Okay, so for each function, tell whether y varies directly with x. If so, find the constant of variation. Okay, the dead giveaway in this one that it is not a direct variation is that plus 7. A direct variation has no plus anything, no minus anything. So this one is not a direct variation. And it is because of this guy right here. Okay. All right, now looking down here, we don't have any plus anything, so this is going to be a direct variation. And we want it in the form of y equals kx. So that means I want this y by itself. So right now we're multiplying it by a negative 2. That means we need to divide both sides by negative 2, which leaves us with y equals negative 5 over 2x. Okay, so the negative 2's cancel out. You have 5 over negative 2, which is the same as negative 5 over 2, and then you have that x. So the constant of variation in this case is negative 5 over 2. Okay, so these are the two components of the answer that we've been asked for. We have the equation, and then and we know that it varies directly, and then we also have the constant of variation. Okay, example 3. A dripping water faucet wastes a cup of water if it drips for 3 minutes. The amount of water wasted varies directly. Right there, that is a key word that tells us that this is a direct variation. It varies directly with the amount of time the faucet drips. So what you have is the amount of water wasted is represented as W. K is your constant of variation, and then the time is T. Excuse me. And we're told that a dripping faucet wastes a cup, that's 1 cup of water if it drips for 3 minutes. So the amount of water wasted is 1 cup, the time is 3 minutes. So we have 1 equals K times 3. The constant of variation is 1/3, and so W equals 1/3 T is the equation. All right, the perimeter of a square varies directly as the length of a side of the square. Okay, so again, we have varies directly as the length of a side of the square. So perimeter varies directly as the length of the side of the square. Formula P equals 4S relates the perimeter of to the length of a side. Well, this, if you wanted to think of it as y equals 4x, you can, because that is the exact same thing. So the constant of variation then is 4, okay? So your constant of variation is 4. Part B says find how long a side of the square must be for the perimeter to be 64. So your perimeter is 64. So we have 64 equals 4s. Divide both sides by 4, and you're going to have s equals 16. The unit is 16 centimeters. Okay, so a side of that square would be 16 centimeters long. Okay, I think there's one more example. I need to double check though. And then, yeah, and then we're done. Okay, oh, this is probably the easiest part, but also the part that can be the most confusing without a good example. Okay, using proportions to find your constant of variation or to find a missing element. All right, so looking at the textbook example, suppose y varies directly. Again, keyword, that means that we have constants of variation, okay? So varies directly with x, and x is 27 when y is negative 51. Find x when y is negative 17. So we have 2 points. We have 2 points on the graph. So what this means to us is that the constant of variations, because they're the same on a graph, so the constant of variation is the same for any points that are on the same graph. These vary directly. K equals K. Well, we know that K from that first slide is equal to y divided by x, right? So then what that means is y divided by x is equal to y divided by x. You have 27, that goes here. You have negative 51, that goes there. You have this 17, that goes here. And you're looking for the x. You cross multiply and you solve for your missing variable. Very, very, very easy. Okay. All right, so let's take a look at this one. So again, suppose y varies directly with x. So then we know the constant of variations are the same. And uh, when y equals 15, when x is 27, find y when x is 18. And we know, again, k is equal to y over x. All right, so we've got y and we have x, and they have it written down here nicely, but they don't always have it written like that, so I want to focus on this part. So y is 15 and x is 27. So y is 15 and x is 27, because we do y divided by x equals, find y when x is 18. Now we cross multiply. We have 15 times 18 equals 27y. Divide both sides by 27. Right? And this is then, because those 27s cancel out, and then you're going to have, oh, I think my brain is not wanting to work. But I think you've got 10. But double checking just to be on the safe side, because heaven knows I make more mistakes than anybody else on the planet. 15 times 18 equals, yeah, that's 10. Okay, so our missing element, y, there we go, equals 10. And that is your answer. So anytime that you have varies directly, you just have y divided by x equals y divided by x, cross multiply, and solve for the missing piece. All right, guys, relatively speaking, this is not a bad lesson to have to be taught in this manner. I apologize that I'm not there personally to answer questions as they arise, but please feel free to email me as they do, because then I can answer them. Also, we will answer any questions you guys have tomorrow and look at the review, because we will be testing on Wednesday. Okay? Have a great day, guys. I'll see you soon.